internet connection. Not everybody is going to have an integrated access device which could allow us to do both phone call and web communications. At least at the beginning of this story, most people are going to have an internet connection and a telephone connection, and the telephone connection is going to be POTS, plain ordinary telephone service. So how do we get that story integrated with the one that we just covered? This diagram shows not so much the integration of the media communications like voice or video, but integration of the signaling systems. And this is where a user who's got a separate connection for internet and then plain ordinary telephone service goes through the self-serve application, reserving a plane ticket like we were talking about in the previous discussion. They run into trouble and there's a button that says click to make your phone ring. And what you do is you type in your phone number and click submit. Now what the user's done is they typed in the phone number into their computer, and when they click the button, they're transferring their phone number to the web server that's been generating these pages that they look at. And the web server will then initiate a communication session down to something called a T server at this call center, telecommunications server, and it will be able to communicate with the telephone company's SS7 signaling network over PRI trunks or what have you, and it will set up a phone call from the middle. And on one side, it'll make a phone call through the regular telephone network to the plain ordinary telephone service telephone sitting beside the customer. And on the other side, it'll deal with the local exchange carrier and the automated call distributor in order to establish a phone call to an agent. And then it's going to connect the two of those things together. So you were on a web page, you typed in your phone number, you clicked a button, and your regular phone that's not connected to the internet just rang, and you're talking to somebody at a call center who's got the same screen as you do in front of them. So this gives you an idea of the power of some of the things we're talking about, especially when we start integrating web and telephone company control systems. It also has some implications. Since none of this is dependent on where any of the pieces are located, it's all connected together via IP packets, that means that all sorts of different organizations can start going into the telephone switching business. Because as soon as we give you the capability from a web server to send a message to the telephone company's SS7 system to make phone calls like this and then connect them together, that means that you can be a telephone company and provide that switching service. So there are all sorts of fun things coming down the road besides just voice over IP, especially when we start thinking of all of the signaling interconnections that are going to happen. To wrap things up, we'll just take a view towards the future. Voice over IP, and in fact multimedia over IP, is a big step forward towards the holy grail in the telecommunications business. Traditionally in telecommunications we have one service for voice, another one for data, and a third one for video. And if you're a large organization, you phoned up a carrier and said, we need a voice data solution, they'd send two people, one from the voice department, one from the data department. They wouldn't know each other. They'd come in different cars. They wouldn't be familiar with each other's products and services. They'd make you get separate access circuits to their network for the voice and the data. You'd get two different bills that were completely different from two different billing systems. Let's not talk about cable TV versus the telephone company. What we're trying to do is to get towards service integration. Now, people call this convergence sometimes, but I don't really like that term because when people say convergence, sometimes they mean cable TV and telephony converging. Sometimes they mean voice and data converging. Sometimes they mean twisted pair and coaxial cable being the same thing. A lot of times they don't really know what they mean when they say convergence. The correct term in this business is service integration. And the idea is that we have one access circuit to the carrier. We have one service that handles both voice, video, and data, and both the commercial data and internet data. We get one bill for all of this stuff. We have one set of technicians that know how to handle all these. We don't have data technicians and voice technicians in a data department and voice department. This is all now unified. And we end up with only having to have one help desk and one set of in-building infrastructure. This is the holy grail, and you can imagine the cost savings that big organizations are going to be able to realize if we could get to one service, one wire, one help desk, one set of technicians, and one bill. Now, as far as value-added services go, some examples of what we're going to have: web-based control information to profile what disposition should be done with your telephone calls. So it'd be based on where you are and who's calling as to what happens. So say, for example, you're in the office, but you don't want to be disturbed. Well, in this case, you would not be notified of email messages coming in, except from these different addresses. You wouldn't be notified of any phone calls coming in, except for that particular network address. If they're calling you, then we're going to let that through. If you're in your car, then you might have a different disposition of communication sessions. So some stuff might come through, but it would just be an alert on your PDA that you should probably check your voicemail rather than actually having the phone call come through. If you're in a hotel somewhere, then what we're going to do is we're going to move all of this stuff to voicemail, but we're going to send these phone calls through. Or if you're at another location or organization. So based on your location, you're going to be able to set up tables on a web type interface that say what different types of communication sessions should experience and exceptions to each of these. And we might call that call disposition profiling. As we get more sophisticated, the network is going to be aware of where you are, and then you will have a profile as to what to do. So you won't have to press *91 to turn follow me roaming on to tell the system that I'm not at my desk anymore, I'm now using my cell phone, so please send the phone calls there. And even with that old system from cellular, you couldn't forward your telephone remotely to your cell phone. You had to actually be at your phone. What we're going to have is automatic registration. So if you're sitting at your desk, then the system will know that and everything will come to your desktop or your telephone. If you're using your mobile, the system will know that and it'll use your call disposition profile. If you're at a hotel, the network will know that you're at that hotel, and based on your call disposition profile, will automatically route phone calls to that hotel telephone. People called this idea personal communication services, and it's part of the holy grail in the telephone business, besides service integration, is to have services associated with a person. Not services associated with a pair of wires on the phone or a particular cell phone number or a particular email account, but instead go one level higher than that and have services associated with a person regardless of where they are. Now, this was called personal communication services in the telephone business for the last 30 years, but then that term was stolen to mean second generation cellular, and so we're now searching for an official term to refer to this idea. But what we want to end up with is sophisticated call handling and network awareness of where you are, and then looking up with profiles to see what to do with phone calls and emails and faxes depending on